Hi, welcome to Engage New York. This is concept development for Module 4, Lesson 15. And this lesson here, our focus, our objective is to multiply non-unit fractions by non-unit fractions. Well, I think it is actually non-unit fractions by non-unit fractions. So let's just look at this problem. How does this problem here look different than the problems that we did in the lesson before, in lesson 14? Well, in every problem we did yesterday, one of the factors had a numerator of 1. So yesterday, or in the previous lesson, one of the fractions was a unit fraction. So there are no numerators that are 1s today in this lesson. Every problem multiplied a unit fraction by a non-unit fraction, or a non-unit fraction by a unit fraction. So this is 2 non-unit fractions. So let me just start by asking you, what is 1/3 of 3/4? We did these yesterday, right? We know, so if you took 1/4 plus 1/4 plus 1/4, and we took 1/3 of 1/4, what is 1/3 of 1/4? 1/3 of 3/4. It is 1/4, right? So that's what we were doing yesterday. So if 1/3 of 3/4 is 1/4, what is 2/3 of 3/4? What do you think? 2/3 of 3/4. Well, 2/3 would just be double 1/3, so it would be 2/4. Now, you can just look at this and know that you can cross cancel and end up with 2/4, and 2/4 is the same as what? 1/2, right? So 3/4 is 3 equal parts, right? So 1/3 of that would be 1 part, or 1/4. So we want 2/3 this time. So that is 2 parts, or 2/4. So name 2/4 using halves. 1/2, right? So 2/3 of 3/4 is 1/2. So that's not really the big idea behind this lesson, is it? Right now in this lesson, and let's see, I think this is going to do it for using, this lesson is going to be the last of using these rectangular fraction models for a little bit. And then we're going back to tape diagrams. So let's go ahead and just practice. Let's draw a rectangular fraction model to show the product and check our thinking. Let's just check to make sure we did that correctly, okay? So let's get, okay, so we have 3/4. Let's draw 3/4 down here, and then our 2/3 goes here, right? Our first fraction, we made an agreement to put on the side, right? Just to be consistent. But if that doesn't work for you, change it. It's not that big of a deal. Because of the commutative property, it really doesn't matter, right? Okay, so now think about this for a second. If we go back up here, if we multiply 2 times 3, Remember, this is multiplication, and this is also considered an area model. So 2 times 3 equals 6, right? And 3 times 4 equals 12, right? So 6/12 is also equal to 1/2, right? So now let's come back here and we need to, oh, I didn't do this correctly. We need to shade in 2/3. I'm so used to doing 1/3. We need to shade in 2/3 of this rectangular fraction model, right? And now we're going to double shade 3/4. So 1, 2, 3. And remember, we only shade in what's already shaded. So we're going to take 1, 2, 3 of the fourths and double shade, right? So now how many boxes are double shaded? 1, 2, 3, 4, 5, 6, right? 6 of the 12ths, because now we broke that into 12 equal groups, correct? All right, so we now have to take, here's 2/3, and we shaded, and 3/4, and we shaded, and we multiplied. 2 times 3 is 6, 3 times 4 is 12, is equal to 1/2. Does that come back up and match what we did up here? So yes, they do match. So do they represent the same product, or did we make a mistake? No, they actually represent the same value, correct? So the unit here, when we went here, because we cross-canceled, units might look different, but 6/12 is the same as or equivalent to 2/4, correct? So in the rectangular fraction model, there are 12 parts, and we shaded 6 of them. That's half. So both of our approaches, or even all 3 of our approaches here, simplifies to 1/2, right? So if we wrote this as a multiplication sentence, it would be 2/3 times 3/4 equals 6/12, which equals 1/2. So this is the actual multiplication sentence. Don't forget about that. Okay. So now we're moving on to problem 2. Let's solve 2/3 by 2/3. So 2/3 of 2/3 by drawing, let's use a rectangular fraction model and then write the multiplication sentence, okay? So what patterns do you see between this problem and the last? Well, this problem has the same pattern as the previous problem. When you multiply the numerators, you get the numerator of the double shaded part. Does that make sense? You get the numerator. When you multiply the numerators, you get the double shaded part, right? When you multiply the denominators, you get the double shaded part. So it's kind of cool. It's matching up. The denominator of the product gives us the area of the whole rectangle, and the numerator, so it'll be 3 by 3, and the numerator of the product gives us the area of the double shaded part. So let's go ahead and attempt this. So we see that the product of the denominators tells the total number of units, and the total number of units is going to be 9. The product of the numerator tells us the total number of units is going to be what? 4, right? 3 times 3 is 9. So we should end up with 4/9 totally double shaded. All right, so let's try it out. Thirds times 2/3. So let's go ahead and draw it out. I have to remember to shade in 2/3. I'm so used to doing the single unit. Now we're going to shade in 2/3. So here's 1, 2, 3. We're only going to shade in 2/3 of what we've already shaded. All right, did we end up with 4/9? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Yes, we ended up with 4/9, right? So 2 times 2 over 3 times 3 equals 4/9. Correct? Correct. All right, moving on to problem 3. Whoops. Okay. 7/9 of 3/7. Wow, 7/9 of 3/7. That's a lot. You're taking a piece of a piece, a portion. You're taking a huge portion of what just a little bit that you have left. So how would this problem look if we drew a rectangular fraction model for it? Think about it. Well, if you just multiplied across, you'd have 63 units, right? 9 times 7 is 63. We'd have to draw 3/7 first and then split each seventh into nines. We'd end up with a model showing 60/3. It would be really hard to draw. So it's not really practical to draw a rectangular fraction model for a problem like this because the units are too small, it's too cumbersome. So could the pattern that we noticed in the multiplication sentences help us though? Yeah, it can. So 7/9 of 3/7 is the same as 7/9 times 3/7, correct? We know that. All right, so our pattern lets us just multiply the numerators and denominators. So, but for me personally, I can see there are numbers hiding in here. So instead of, technically we could go 7 times 3 is 21 over 9 times 7 is 63. That's quite a large fraction to have to simplify. So I suggest 7/9 times 3/7, and I would start cross canceling. So 7 goes into 7 once, 7 goes into 7 once. So now we've taken that out. Now 3 goes into 3 once, 3 goes into 9 3 times. So, oh my gosh, we have just reduced that down to 1/3. That is so much easier to deal with, right? It just makes so much more sense to use cross canceling to simplify our answer. And we know whenever we have a fraction, it is truly you should always simplify your fraction. You should not leave your fraction in such a large with those amount of units when you can show that same fraction in a much more simplified way. All right, so we're going to do the same thing with these two fractions right here. Go ahead and you can use either method, but I have to say method 1 is going to make you have to simplify, and you already had these numbers sitting in here, so why wouldn't you get rid of them anyway? Method 2 makes life a whole lot easier. So by renaming the fractions and dividing, you've just made your answer number 1 in the correct form that you need to present it in. And you've made your life a whole lot easier on having to multiply instead of having to come off over here and possibly multiply. So what your job is going to do right now is I want you to try to use cross-canceling to solve 3/10 of 5/9 and 5/8 of 4/15, and then come back to check your work. Okay, how did you do? Now, I started by just simply multiplying across, and I also came up here and I just straight up cross-canceled. I have to say this, I don't want to deal with 15 over 90. It's 90 separated pieces. I'd rather deal with sixths. So 3/10 of 5/9 is 1/6. And then over here, what would you rather deal with? 20 over 120 or 1/6? So I highly recommend the cross-canceling method. Okay, last problem. In this problem, we're going to use a tape diagram. So let's solve this using a tape diagram. So let's go ahead and draw out a tape diagram. Leave yourself enough room to actually do some work though. Don't draw it too big. Okay. Nigel completes 3/7 of his homework immediately after school and 1/4 of the remaining homework before supper or dinner. He finishes the rest after dessert. What fraction of his work did he finish after dessert? Well, what fraction of his homework does Nigel finish immediately after school? 3/7, right? So let's partition the diagram, the tape diagram, into sevens and label 3 of them completes after school. So let's break this into sevens. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Now we're going to label 3 sevens completes after school. And remember, write down the fractions so you can keep track. All right, now, what fraction of the homework does Nigel have remaining? He has 4/7, right? So what fraction of the remaining homework does Nigel finish before supper? Well, they say 1/4, right? So the remaining units on the tape diagram, what is 1/4 of the remaining? So 1/4, then what? So 1/4 of 4/7 is 1/7, right? So right here, we're going to put 1/4 remaining after completes before supper. We're going to draw this before supper. So do you see how we got that? Because this was taken away and he did 1/4. So 1/4 of the remaining is right here, right? 1/4. So here is where we're left with, well, when does Nigel finish the rest of his homework? Well, after dessert, right? So answer the question with a complete sentence. Nigel completes, so here is completes after dessert, right? Okay, so so the question is, what fraction of his work did he finish after dessert? Well, what is left? 3/7 is left. That's the answer to the problem. Nigel completes 3/7 of his homework after dessert. So always write that in a complete sentence. Nigel completes the rest of his homework after dessert is equal to 3/7, right? So he completes 3/7 of his homework after dessert. Now, so we did just answer the question. That's done. And we did it simply by drawing a tape diagram, right? So now let's imagine that Nigel spent 70 minutes to complete all of his homework. Where would I place that information in the model? He completes 70 minutes. Nigel spent 70 minutes to complete all of his homework. Like if you put all the times together, it would equal 70 minutes. Where should that go? So put 70 minutes above the diagram, right? This here equals 70 minutes, right? Okay, so now put 70 minutes here on your diagram. We just found out the whole, so we can label it above the tape diagram. So how could I find the number of minutes he worked on homework after dessert? So think about it for a second. So he finished 4/7 already, so we can find 4/7 of 70 minutes and then subtract that from 70 to find how long he spent after dessert. It's a fraction of a set. He does 3/7 of his homework after dessert. We can multiply 3/7 of 70. That's how long he worked after dessert. We can first find the total minutes he spent after school by solving 3/7 of 70. 3/7 of 70. And what is that going to give us? Well, 7, let's turn that at 7 goes into 7 once. 7 goes into 70 10 times, right? So 3 times 10 is 30 minutes. Okay, so think about that. So this is equal to 30 minutes, right? So we know, so if you spent 3, if this 3/7 is equal to 30 minutes, so how much will each one of these equal? Well, 10, right? So 3/7 is equal to 30 minutes. So this 3, if you broke that up, 3 divided by 3 is 10, right? So we know Nigel spent, so now how much was left that Nigel spent after dessert? So Nigel spends 30 minutes working after dessert. So this is just an extension, this part of this. But being able to find and break this down and find those little nuggets right there is, you never know. A problem could definitely be extended. And I would definitely expect something like that on one of the state tests or a proficiency test. I think that would be totally appropriate where they would extend your problem. All right, so that's going to do it for our concept development. Let's just take a look at the problem set really quick. Okay, so problem set. Just like we started off, remember, you're supposed to solve and draw a rectangular fraction model to explain your thinking. Then write that multiplication sentence. So instead of leaving it 3/4 of 4/5, you need to write 3/4 times 4/5 is equal to. Okay, so draw your rectangular fraction models, write your multiplication sentence to have it match. Then here, multiply, draw a rectangular fraction model if it helps you, or use a method in the example. What is that method? Cross canceling. Okay. Here's two more that I suggest you use cross canceling. Then, Philip's family traveled 3/10 of the distance to his grandmother's house on Saturday. They traveled 4/7 of the remaining distance on Sunday. Okay, this goes right back to using what we just did with Nigel. I would definitely use a tape diagram here. What fraction of the total distance to his grandmother's house was traveled on Sunday? Tape diagram that. All right. So I would have my tape diagram broken up into tenths. I would show 3/10. What is left? Oh, 10 minus 3 is 7, right? So of that 7 that's left, 4/10 was traveled on Sunday. What fraction of the total distance to his grandmother's house was traveled on Sunday? Okay. All right. So now Santino bought a 3/4 pound bag of chocolate chips. So it's not a full pound, it's only 3/4 of a pound bag. So they sold it. So how many ounces are in a pound? 16 ounces. So 3/4 of 16 would be 12 ounces, right? So just nugget of knowledge there. He used 2/3 of the bag while baking. So 2/3 of 3/4. How many pounds of chocolate chips did he use while baking? So you're going to need to go back to knowing, make sure you know that there are 16 ounces in a pound. All right, Farmer Dave harvested his corn. He stored 5/9 of his corn in one large silo and 3/4 of the remaining corn in a small silo. So large silo, small silo. The rest was taken to market to be sold. So I definitely would use a tape diagram to show this. What fraction of the corn was stored in the small silo? Then, if he harvested 18 tons of corn, how many tons did it take to go to market? Did he take to market? Remember, how many pounds are in a ton? Remember, there are 2,000 pounds in 1 ton, but I don't think you actually need to know that here. Just simply do the multiplication. All right, you should do well and come back to check your work after you have completed the problem set to make sure you're on track to do the homework. So remember, completing the problem set and checking your work will help you know how to attack, or the method for helping you with the homework.